is Kavithaa Suresh Kumar, and I am teaming up with Sudipto Sarkar for the final project of DLH. The paper we have chosen is HiCu, Leveraging Hierarchy for Curriculum Learning in Automated ICD Coding. Clinical notes are an important healthcare data. These are unstructured texts that are entered by the clinicians to record the patient's details. These texts contain many diagnosis and procedural terms. These terms have to be mapped with ICD codes, and mapping these ICD codes manually has a higher error rate. Hence, deep learning algorithms are used to map these codes. HiCu is one such algorithm which uses the inherent hierarchical structure of the ICD codes to create this mapping. The architecture of the HiCu is an encoder-decoder model. The encoder takes a clinical notes as the input and gives a word representation. This model particularly uses bi-LSTM, multi-res CNN, and RAC reader. The decoder is an per-label attention network which aggregates the output from the encoder and uses a classification head predicting the ICD codes. It also has the hyperbolic embedding to transfer the knowledge from one step of the curriculum to the next level. In this particular paper, they are using PointCare from the GenSim library. The ablations we have tried is to remove the level 2 of the diagnosis code variable and show that the performance is lesser than the original HiCu paper. And also we have changed the optimizer from Adam to Raymond-Adam optimizer to show the results are better than the original HiCu model. The last one we have done is to reduce the number of epochs to avoid the computation overhead and possible overfitting of the labels and prove that the model performance equally good or better. Now my friend Sudipto will take over. Thank you.
Hello everyone. I will do a quick walkthrough of the code. You can see the code changes. The first change we did was to the optimizer in main.python. We used a Riemannian Adam model. Then we also used the ICD hierarchy.python file for the ablation changed, where we first changed the root diagnosis variable. We removed the level 2 hierarchy that was defined in HiCu. Then we made changes to the logic for how other levels are created for both diagnosis and procedure code. Then we also made changes to the parameter, where we use the 50 code dataset. We use a defined batch size, different number of worker processes, and different epochs. We'll also show you the results quickly. You can see the changes to the AUC and F1 scores between the before and after run, thereby justifying the need for the HiCu hierarchy. And then we also see the difference in the evaluation times, therefore showing the improvement due to the optimizer. Now I will quickly show you the run through of the code. We already ran it before, and this is how the run looks like. And you can see the results here. I'll also do the run quickly to show you how we came to the results. So you can see that it will start building the model first, and then it will use the 50 code dataset, and finally it will start building the epochs, the epoch 0. So you will see that happening soon. So here's the model, and then it will start using the 50 code dataset. There you go. And then finally it will use the epoch. So that's a quick run through of the code. Thank you.